The Osgi Alliance, formerly known as the Open Services Gateway Initiative, is an open standards organization founded in March 1999 that originally specified and continues to maintain the Osgi standard. The Osgi specification describes a modular system and a service platform for the Java programming language that implements a complete and dynamic component model, something that does not exist in standalone Java VM environments. Applications or components, coming in the form of bundles for deployment, can be remotely installed, started, stopped, updated, and uninstalled without requiring a reboot. Management of Java packages, classes is specified in great detail. Application lifecycle management is implemented via APIs that allow for remote downloading of management policies. The service registry allows bundles to detect the addition of new services, or the removal of services, and adapt accordingly. The Osgi specifications have evolved beyond the original focus of service gateways, and are now used in applications ranging from mobile phones to the open-source Eclipse IDE. Other application areas include automobiles, industrial automation, building automation, PDAs, grid computing, entertainment, fleet management and application servers. Specification process. The Osgi specification is developed by the members in an open process and made available to the public free of charge under the Osgi specification license. The Osgi Alliance has a compliance program that is open to members only. As of November 2010, there are 7 certified Osgi framework implementations. A separate page lists both certified and non-certified Osgi specification implementations, which include Osgi frameworks and other Osgi specifications. Architecture. Any framework that implements the Osgi standard provides an environment for the modularization of applications into smaller bundles. Each bundle is a tightly coupled, dynamically loadable collection of classes, jars, and configuration files that explicitly declare their external dependencies. The framework is conceptually divided into the following areas. Bundles. Bundles are normal jar components with extra manifest headers. Services. The services layer connects bundles in a dynamic way by offering a publish-find-bind model for plain old Java interfaces or plain old Java objects. Services registry. The application programming interface for management services. Lifecycle. The application programming interface for lifecycle management for bundles. Modules. The layer that defines encapsulation and declaration of dependencies. Security. The layer that handles the security aspects by limiting bundle functionality to predefined capabilities. Execution environment defines what methods and classes are available in a specific platform. There is no fixed list of execution environments, since it is subject to change as the Java community process creates new versions and editions of Java. However, the following set is currently supported by most Osgi implementations. CDC 1.0, Foundation 1.0, CDC 1.1, Foundation 1.1, Osgi, Minimum 1.0, Osgi, Minimum 1.1, JRE 1.1, from J2SE-1.2 up to J2SE-1.6. Bundles. A bundle is a group of Java classes and additional resources equipped with a detailed manifest MF file on all its contents, as well as additional services needed to give the included group of Java classes more sophisticated behaviors, to the extent of deeming the entire aggregate a component. Below is an example of a typical manifest MF file with Osgi headers. Bundle name. Hello World Bundle Symbolic Name. Org. Wikipedia. Hello World Bundle Description. A Hello World Bundle manifest version. 2 bundle version. 1.0.0 bundle activator. Org. Wikipedia. Activator export package. Org. Wikipedia. Hello World version equals 1.0.0 import package. org.osgi.framework, version equals 1.3.0. The meaning of the contents in the example is as follows. Bundle name defines a human-readable name for this bundle, simply assigns a short name to the bundle. Bundle symbolic name. The only required header. This entry specifies a unique identifier for a bundle, based on the reverse domain name convention. Bundle description. A description of the bundle's functionality. Bundle manifest version. Indicates the Osgi specification to use for reading this bundle. Bundle version. Designates a version number to the bundle. Bundle activator. Indicates the class name to be invoked once a bundle is activated. Export package. Expresses which Java packages contained in a bundle will be made available to the outside world. Import package. Indicates which Java packages will be required from the outside world to fulfill the dependencies needed in a bundle. Lifecycle. A lifecycle layer adds bundles that can be dynamically installed, started, stopped, updated and uninstalled. Bundles rely on the module layer for class loading but add an API to manage the modules in runtime. The lifecycle layer introduces dynamics that are normally not part of an application. Extensive dependency mechanisms are used to assure the correct operation of the environment. Lifecycle operations are fully protected with the security architecture. Below is an example of a typical Java class implementing the bundle activator interface. Package org, Wikipedia, import org.osgi.framework.bundleActivator, import org.osgi.framework.bundleContext. Public class activator implements bundle activator, private bundle context at override public void start throws exception system.out.println this.context equals context. At override public void stop throws exception system.out.println this.context equals null. Services. Standard services. The Osgi Alliance has specified many services. Services are specified by a Java interface. Bundles can implement this interface and register the service with the service registry. Clients of the service can find it in the registry, or react to it when it appears or disappears. The table below shows a description of Osgi system services. The table below shows a description of Osgi protocol services. The table below shows a description of Osgi miscellaneous services. Organization. The Osgi Alliance was founded by Ericsson, IBM, Motorola, Sun Microsystems and others in March 1999. Before incorporating as a non-profit corporation, it was called the Connected Alliance. Among its members are more than 35 companies from quite different business areas, for example Adobe Systems, Deutsche Telekom, Hitachi, IBM, Liferay, Makewave, NEC, NTT, Oracle, Orange SA, Prosist, Salesforce.com, Siemens, Software AG and TIBCO Software. The Alliance has a board of directors that provides the organization's overall governance. Osgi officers have various roles and responsibilities in supporting the Alliance. Technical work is conducted within expert groups chartered by the board of directors, and non-technical work is conducted in various working groups and committees. The technical work conducted within expert groups include developing specifications, reference implementations, and compliance tests. These expert groups have produced 5 major releases of the Osgi specifications. Dedicated expert groups exist for the enterprise, mobile, vehicle and the core platform areas. The Enterprise Expert Group is the newest EG and is addressing enterprise, server-side applications. In November 2007, the Residential Expert Group started to work on specifications to remotely manage residential home gateways. In October 2003, Nokia, Motorola, IBM, Prosist and other Osgi members formed a Mobile Expert Group that will specify a MIDP-based service platform for the next generation of smart mobile phones. addressing some of the needs that CLDC cannot manage, other than CDC. MEG became part of OSGI as with R4. Community. Eclipse itself includes sophisticated tooling for developing OSGI bundles, and there are a number of other Eclipse plugins aimed at supporting OSGI behavior. There is a vibrant free software community revolving around the OSGI specification. Some widely used open-source implementations are Equinox, Apache Felix and Knopflerfish OSGI specification versions. OSGI Release 1, May 2000. OSGI Release 2, October 2001. OSGI Release 3, March 2003. OSGI Release 4, October 2005, September 2006. Core Specification, October 2005. Mobile Specification, September 2006. OSGI Release 4.1, May 2007. OSGI Release 4.2, September 2009. Enterprise Specification, March 2010. OSGI Release 4.3, April 2011. Core, April 2011. Compendium and Residential, May 2012. OSGI Release 5, June 2012. Core and Enterprise, June 2012. OSGI Release 6, June 2014. Core, June 2014. New in OSGI Release 4. The new features of OSGI R4 in brief are as follows. New modularization capabilities, providing enhanced encapsulation of networked services that can share a single virtual machine. Modularized class sharing and hiding of implementation details. Methods for handling multiple versions of the same classes so old and new applications can execute within the same VM. Localization of OSGI bundle manifests, enabling service deployment anywhere. Enhancements in security and policies. The new conditional permission admin service provides an elegant and simple way to manage networked services securely. It also supports dynamic policies that can depend on external conditions, combined with R4 support for digital signatures. This provides a central security solution to large deployments of products using the OSGI service platform. A declarative services specification that addresses memory footprint issues that can prevent small embedded devices from using a service-oriented architecture to support multiple applications. Additionally, it significantly simplifies the service-oriented programming model by declaratively handling the dynamics of services. Compatibility with Release 3, requiring no changes for existing OSGI bundles, applications, or services. New in Release 4.1, OSGI R4.1 was a minor revision intended to clarify certain aspects of bundle initialization and loading in order to improve third-party usage. It added no new services or major features. New in Release 4.2, OSGI R4.2 was a significant release that added several new services and capabilities, including framework launching, standardized means to launch OSGI from various providers. Remote services allows the exporting of services to remote VMs. Blueprint service, dependency injection and inversion of control that allows external configuration of bundle dependencies. Bundle tracker, track and respond to changes in bundle presence and state. Service hooks allow introspection and behavior modification of service calls to inject security or dynamicism. Conditional permissions support negative permissions, forbidding specific actions instead of just allowing them. More information can also be specified in each bundle header, such as license information, MIME types and icons. Additionally, changes to declarative services allow the easier setting of permissions. Finally, OSGI bundles can now have their return values read. OSGI R4.2 also introduced a new specification release for the enterprise, including support for web applications. a standardized format for building OSGI web applications packaged using the WAR file format. JPA service provides a reliable standard mechanism to use the Java Persistence API in OSGI. JNDI service allows integration of the OSGI service registry in the Java naming and directory interface. JDBC service provides an OSGI lifecycle aware mechanism to obtain connections to an external database. New in Release 4.3 generics. The framework now uses JDK5 generics in several places. However, Java 1.4 can still be targeted using Source 1.5 target JSR14 switches to Java-C. Capabilities: a set of attributes in a namespace in a module's meta-information, such as osgi.wiring.package export package. Requirements: a filter expression over the attribute set of a capability, such as osgi.wiring.package import package. Adapt replaces framework services, adapts bundle to another type, replaces package admin and start level services with APIS, which a bundle can be adapted to. Weaving hook. The weaving hook services allows load time bytecode weaving, resolver hooks and bundle hooks. Replaces the nested frameworks and composite bundles proposal with low-level capabilities to influence requirement capability matching. Service event listener hook replaces service event hook with finer-grained event delivery control. New in Release 5.0. New in Core Release 5 Resource API for modeling generic capabilities and requirements. Version range class. New in Enterprise Release 5 removed Remote Services chapter to the Compendium, moved the tracker to the core, added the Resource API specification on page 127. This generified the framework's requirement capability model. This affected the module layer and the wiring API. Related RFCs and Java specifications. RFC 2608. SunJINI. SunJCP-JSR8. SunJCP-JSR232. SunJCP-JSR246. SunJCP-JSR249. SunJCP-JSR277. SunJCP-JSR291. SunJCP-JSR294. Related standards. MHP, OCAP, Universal Plug and Play, DPWS, ITUTG.HN, Lonworks, Corba, CBOOS, EHS, CECD Chain, Java Management Extensions, projects using OSGI, Apache Aries, Blueprint container implementations and extensions of application-focused specifications defined by OSGI Enterprise Expert Group. Apache Sling, OSGI-based applications layer for JCR content repositories. Atlassian Confluence and JIRA. The plugin architecture for this enterprise wiki and issue tracker uses OSGI, Business Intelligence and Reporting Tools Project, open source reporting engine. Cytoscape, an open-source bioinformatics software platform. Data Nucleus, open-source data services and persistence platform in service-oriented architectures. DOTCMs, open-source web content management. EasyBeans, open-source EJB3 container. Eclipse, open-source IDE-enriched client platform. IDEMPIA is an OSGI implementation of the open-source ERP branch Global XIDEMPIA 361 originally started by Lo Heng Sin. Eclipse Virgo, open-source microkernel-based server constructed of OSGI bundles and supporting OSGI applications. Glassfish, application server for Java EE. Fuse ESB, a productized and supported release of Service Mix 4. Service Mix. Apache Service Mix is a flexible, open-source integration container that unifies the features and functionality of following components. Apache ActiveAC, Apache Camel, CXF, and Apache Karif into a powerful runtime platform. The components are always really outdated. You can use Service Mix to build your own integration solutions, and it provides a complete, enterprise-ready ESB exclusively powered by OSGI. GX Web Manager Community Edition, an enterprise web content management system based on OSGI, Spring and JCR. Kara, Eclipse IoT open source project for M2M applications. IntelliJ, Java IDE Rich Client Platform with Free Community Edition. JBoss, Red Hat's JBoss Application Server. Jonas 5 Open Source Java E5 Application Server. JOSSO2 Attributes Open Source Standards-Based Identity and Access Management Platform. Liferay, a free and open source enterprise portal platform. Lucy 5 Open Source CFML Web Application Server. NetBeans, Open Source IDE Rich Client Platform. Nuxt.io, Open Source ECM Service Platform. Open Daylight Project with the goal of accelerating the adoption of software-defined networking. OpenApe, Open Source OSGI-enabled EJB 3.0 container that can be run both in standalone or embedded mode. OpenWorm, open source software simulation of C. elegans via the dedicated Geppetto modular platform. Parimus Service Fabric, an automated, distributed OSGI runtime, PaaS. SOA software, API gateway, portal and analytics server from Akana. Spring Source DM server, open source microkernel-based server constructed of OSGI bundles and supporting OSGI applications. WebLogic, Oracle WebLogic Application Server. WebSphere, IBM WebSphere G Application Server. WebMethods, SoftwareArc Web Methods. WSO2 Carbon-based platform for WSO2's enterprise-grade open-source middleware stack. Current framework implementations.